In this lesson, we will graph an exponential function and then identify its domain and range. Graphs of exponential functions. Properties of graphs of exponential functions. Now, the general properties of an exponential function, and you know an exponential function because if you have some number that's greater than 0 but not 1, and it's raised to a power, then that is an exponential function. So they will have pretty much the same properties, and that is the domain of that will be from negative infinity to positive infinity. The range will be 0 to positive infinity. Now, in terms of what the graph looks like, if b, the base of the number, is if it's greater than 1, it's going to be a function that is increasing, which models exponential growth. So in this example here, this is an example of where you notice the coefficient of the base term is greater than 1. So therefore, it models an exponential growth from left to right, moving in an upward exponential form. And the domain of this function, how far it extends to the left or to the right, because we have arrows on both ends, it's going to go to infinity to the left and infinity to the right. So that is why the domain is always from negative infinity to positive infinity. Other characteristics of exponential function, the range will always be from 0 all the way to positive infinity, and the reason for that is because there's a horizontal asymptote at y equals 0, which means that graph will never go below that line. It gets close to it, kind of hugs it, but never really touches the the x-axis there. So your y equals 0 is your horizontal asymptote. So therefore, again, the range would be from 0 all the way to positive infinity. It will go forever up. The other scenario is when the base number is a fraction between 0 and 1. So if you have a fraction, that's going to be an example of a function that is decreasing, and it models an exponential decay. And you know that because moving from left to right, it's going to be moving in a downward motion. One other important characteristic about an exponential function is that one of its points is always going to be 0, 1. So notice with the exponential growth function, the increasing function, 0 and up 1, there's that point. You also see that point in a decreasing function, an exponential k. There it is, 0 and up 1. So other points on the graph would be -1, 1 over whatever the base number is, and another point would be 1, whatever the base number is. So those are certain properties or characteristics of the graph of an exponential function. Here we're given an exponential function and asked to sketch the graph of f of x equals 5 to the x power, and then give the domain and range. So 5 raised to the x. So first of all, my base is 5. That is a number that is greater than 1. So therefore, this is going to be an increasing function and exponential growth. So from left to right, moving in an upward motion. Our points on the graph, recall, is going to be negative 1, comma 1 over b. So if b is 5, that point, the y value would be 1 over 5. Remember, 0, 1 is always on the graph of an exponential function. And then the other point is 1b. If b is 5, the other point on this graph would be 1, comma 5. So let's go ahead and plot those 3 points so that we can graph. Another thing about an exponential function is that there's a horizontal asymptote of y equals 0, which means there's an imaginary line that the graph will not touch, but it will get close to that line. So that when we sketch the graph, it's going to look like so. And so notice we have our points over negative 1 and up 1/5. 0 and up 1, and we also have the point over 1 and up 5. Notice all those points are on the graph. We have our horizontal asymptote. Even though it looks like it touches it, it gets very close, but it never really touches it, because notice here our point is up 1/5. So it gets very close but don't touch. And there you have it. That is the graph or sketch of f of x equals 5 to the x power. Here's another method for solving that same problem, f of x equals 5 to the x power. We can find ordered pair solutions by plugging in a value for x to see what we get out for y. Once you get those ordered pair solutions, plot them and then sketch your graph. So let's go ahead and find a few ordered pair solutions. Let's let x be negative 1, 0, 1, and then 2. So I'm going to begin first by letting x be negative 1. When we do so, we know that any number raised to a negative exponent, you're going to have to flip it to make that exponent a positive. So that flipping process, once you flip it, you're going to have 1 on the top, and that exponent of negative 1 is going to be positive 1, which gives you an output of 1/5. So when you plug in a negative 1, what you get out is 1/5. Next, we will let x be 0, remove the x and replace it with 0. We know that any number raised to the 0 power equals 1, so what we get is an output of 1. Next, letting x be 1, remove the x and replace it with 1 is going to give us 5, because 5 raised to 1 power is still just 5. Lastly, remove the x and replace it with 2. 5 squared equals 25. That gives us an output of 25. And so there we have our ordered pair solutions, negative 1, 1/5, 0, 1, 1, 5, and 2, 25. So now all we need to do is to go ahead and plot these points on the our graph and then sketch our graph. So let's do that. And there you have it. There's your graph. Notice all your points are there. Negative 1, 1/5. That's up a tad bit. Very tiny. Not on the line, but it's a little up from that line. Then you have 0 and 1. And by the way, this graph is in increments of 5, and the reason why is because that was the only way we were going to be able to capture that big y value of 25. So next, over 1 and up 5, and then the other point over 2 and up 25. There you have it. We have our graph. Now the last thing we need to do is find the domain. And the domain, how far it extends to the left and to the right. Because we have arrows on both ends, it's going to go from negative infinity to positive infinity. The range, how far it extends up or down. We know that because we have an asymptote at y equals 0, the line is not going to go below that point. So our range is going to be from 0, and because we have arrows, it's going to extend forever up to positive infinity. And there you have it, sketching the graph of an exponential function.